This question, the position of a car changes with time according to the relation x equal to 4t square minus 2t plus 6. Find position, velocity, and acceleration of the car at time 0. Second part, find the position of the car when velocity becomes 0. All values are in SI units. For this question, we need to learn some rules regarding differentiation. So we'll be checking the rules first before going to the question. The first rule, rate of change of a constant, k is a constant, is always 0. The constant will not have a change. So the change of that quantity in 1 second, which is the rate of change, that is also 0. Rule number 1. For example, in this particular question, we have a constant 6. For any other number 6 or 8, like if you find d by dt of 6, for any number, that will be 0. Now, rule number 2, if you have addition, subtraction terms for finding d by dt, you can open the bracket and do it separate. Meaning, d by dt of any function plus or minus another function is same as doing rate of change, d by dt of the first one, as per the sign, plus or minus, then rate of change of the second part. So you can just open the bracket for addition, subtraction terms with d by dt. Third rule is only applicable to exponents. If it is rate of change of t raised to n. This rule you have to learn directly. The proof may be learned in maths. The exponent will come down as n, and the new exponent after the differentiation will be 1 less than the old exponent. That means d by dt of t raised to n equal to n times the same t raised to n minus 1. The d by dt will go, n will come down. The new exponent for the time will be 1 less than the previous. So here, if you take as an example, it's a t squared. So d by dt of t squared. The 2 will come down, and the exponent t raised to 2 minus 1, which is 1. So 1 we normally don't write. So d by dt of t squared is 2. Even d by dt of t, if you check, d by dt of t will be, t means exponent is 1. So 1 into t raised to 1 minus 1, 0. So d by dt of t will be just 1. I didn't type it. Same rule you can apply here and get d by dt of t will be equal to 1. Now the fourth rule is regarding exponents along with constants, 5t raised to n, 6t raised to n. So in that particular case, you can take the constant simply out. It is d by dt of k times t raised to n. The k will come outside. So k times, you can do the normal rule of d by dt of t raised to n, which is the third rule. If you open the bracket here with differentiation, the k times will be n into t raised to n minus. So here we have 4t squared. So d by dt of 4t squared is same as 4 will go out and d by dt of t squared. If you continue with this, you can apply d by dt of t squared as n into t raised to n minus 1. D by dt of t squared we already got as 2t. So 4 into 2t, 8t. 4 is there. D by dt of t squared becomes 2t, so totally 8. So these are the common simple rules very commonly used for questions like this. Now we are coming back to the question after learning the rules. They given the position. So the position is 4t square minus 2t plus 6. They're asking position, velocity, and acceleration. The position we can find now by putting t equal to 0. But before that, we find the formulas for position already given, velocity and acceleration. Then finally substitute t equal to 0 in all the cases. So for finding velocity, we learn the rule, velocity is rate of change of position with respect to time, d by dt of x. So here just substitute the value of x. So d by dt of 4t square minus 2t plus 6. X is replaced as 4t square minus 2t plus 6. Now this is same as rule number 2. There are addition subtraction terms. What you can do, open the bracket with 4t square one differentiation minus 2t another differentiation, 6 another differentiation. Be d by dt of 4t square minus d by dt of 2t plus d by dt of 6. Now from here we have a constant with a function. So that go to rule number 4. The k will simply come outside. The 4 will come outside as 4 into d by dt of t square. The 2 will come outside as 2 into d by dt of t. D by dt of 6 is a constant. We already know. For a constant, the differentiation will be 0. This will be disappearing 0. Here 4 comes outside. Here 2 comes outside. Now, this is just an exponent. That is rule number 3. D by dt of t raised to n will be n into t raised to n minus 1. If you do for t square, the 2 will come down and t raised to 1, so 2t. So 4 into d by dt of t square will be 2t minus 2 into d by dt of t. T means exponent is 1. So the 1 will come down and t raised to 1 minus 1, t raised to 0, that's 1. So d by dt of t is 1. It will come as 4 into 2t minus 2. 2t because d by dt of t square is 2 and d by dt of t is 1. You can just multiply this term. 4 into 2 is 8, 8t minus. So that's a formula for velocity. Velocity is 8 into time minus 2. Now we have learned acceleration formula. Acceleration is rate of change of velocity. So a equal to d by dt of v. Then you substitute this v formula here. Instead of v, 8t minus 2. So d by dt of 8t minus 2. Here also we have addition subtraction terms. So rule number 2, we are making it separate as 2 terms. So d by dt of 8t minus d by dt of 2. Here we can take 8 outside as per rule number 4. K will come outside. So 8 will go outside. Then d by dt of t minus d by dt of 2. When you open the bracket. But d by dt of 2 is a constant. Differentiation that will be 0. And d by dt of t will be 1. So it will be just 8 minus 0 will be 8. So that's a value for acceleration. This don't have a time. So whatever time you give 0, 1, 2, 3, 4, the value of acceleration remains constant. But velocity changes because it's depending on the time. Position also changes because it's depending on the time. So we got the formulas for position already given. We got the formula for velocity. And we have the acceleration value. Now we are going to substitute as per the question. The question is asking position, velocity, and acceleration when t equal to 0. So t equal to 0, position, this part 4 into 0 will be 0. 2 into 0 will be 0, just 6. So at t equal to 0, position equal to 6 meters. So for velocity, we have formula for velocity 8t minus 2. So when t equal to 0, 8 into t will be 0, it's just minus 2. So velocity will be minus 2 meters per second. Acceleration, it is independent of time. Whatever value you do of time, the acceleration will remain same as 8 meters per second square. So that's the first part of the question. Position, velocity, and acceleration of the car at t equal to 0. Now the second part they're asking, find the position of the car when velocity becomes 0. They gave you velocity as 0. It's given velocity as 0. When you substitute velocity 0, you can bring the velocity formula. Velocity formula is 8t minus 2. When you substitute here, instead of velocity will be 8t minus 2 equal to 0. Now you can take two other side. and solve for t. So 8 and 2 get cancelled for t equal to 1 by 4 seconds. So you got the time. If you know the time, you can find velocity. You already know velocity is 0, then we got the time, you can find the position. Now substitute the t value in the position to find the position of the car when velocity becomes 0. So the position formula is 4t square minus 2t plus 6 here. T will come as 1 by 4, so 1 by 4 square and 1 by 4 instead of this 2. 1 by 4 square is 1 by 16. 4 and 16 will go, 4 will remain the denominator. So 1 by 4 minus 2 and 4 get cut, 1 by 2 plus 6. Now if you take LCM of 4, common denominator, 1 minus here to multiply by 2. So 2 by 4 plus here to multiply 4, so 24. Now we add totally 24 plus 1, 25 minus 2, 23 by 4. That is 5.75 meters. Please check the concept. If you want any help, just respond back to me. Thank you.